What if I told you that the belief that we use only 10% of our brains is a lie? Imagine harnessing the full power of your brain, every neuron and glial cell working in perfect harmony, transforming your thoughts into boundless potential. For too long, we've been misled by this myth, which undermines our true capabilities and diminishes the extraordinary complexity and efficiency of our minds. Brain synchronization is the key to unlocking this hidden potential. It involves the seamless coordination between neurons and glial cells, the collaboration of the left and right hemispheres, and the breaking free from habitual patterns that limit our cognitive flexibility. By understanding and leveraging the full capacity of our brains, we can achieve unprecedented levels of personal growth and transformation. To understand the full potential of our brains, we must first appreciate the intricate dance between neurons and glial cells. Neurons are the brain's communication specialists, transmitting information through electrical impulses that traverse complex networks at lightning speed. These impulses are the foundation of every thought, emotion, and action we experience, enabling us to interact with the world in real time. However, neurons cannot function effectively in isolation. Enter glial cells, the brain's unsung heroes. Glial cells maintain the neural environment, ensuring that neurons have the necessary support to perform their tasks. They regulate the balance of chemicals in the brain, provide structural support, and remove waste products. Glial cells also play a crucial role in modulating the synaptic activity of neurons, thereby influencing learning and memory. Together, neurons and glial cells form a dynamic duo, each complementing the other's functions. This collaboration is essential for maintaining the brain's overall health and efficiency. When neurons and glial cells work in harmony, they create a robust network capable of extraordinary feats, from solving complex problems to experiencing profound emotions. This seamless collaboration extends beyond individual cells to the larger structure of the brain, particularly its hemispheres. The brain is divided into the left and right hemispheres, each specializing in different types of thinking. The left hemisphere is the realm of logic and analytical reasoning. It excels in tasks that require linear thinking, such as mathematics, language, and detailed analysis. In contrast, the right hemisphere is the seat of creativity and holistic thinking. It is responsible for recognizing patterns, understanding spatial relationships, and processing music and art. The right hemisphere allows us to think outside the box, make intuitive leaps, and appreciate the beauty and complexity of the world around us. While each hemisphere has its specialties, optimal brain function depends on the synchronization between the two. When the left and right hemispheres work together, they create a balanced and comprehensive approach to problem solving and creativity. This hemispheric synchronization enables us to draw on the strengths of both logical and creative thinking, leading to more innovative and effective solutions. The importance of this balance cannot be overstated. In our daily lives, we often find ourselves relying heavily on one hemisphere over the other, depending on the task at hand. However, true cognitive excellence is achieved when we integrate both hemispheres, allowing them to complement and enhance each other. This integration fosters a more flexible and adaptive mindset, capable of navigating the complexities of modern life with ease and grace. Brain synchronization, therefore, is not just about the cellular level, but also about harmonizing the larger structures of the brain. By fostering better communication between neurons and glial cells, and encouraging collaboration between the left and right hemispheres, we can unlock the full potential of our minds. This holistic approach to brain function is the key to achieving greater cognitive flexibility, creativity, and personal growth. As we continue to investigate the mechanisms of brain synchronization, we begin to see how interconnected and interdependent these systems truly are. The health and efficiency of our neurons and glial cells directly impact the ability of our hemispheres to work together. Similarly, the synchronization of our hemispheres enhances the overall functioning of our neural networks, creating a positive feedback loop that continually improves our cognitive abilities. In summary, understanding and leveraging the roles of neurons, glial cells, and brain hemispheres are crucial for unlocking our full mental potential. By fostering synchronization at every level of brain function, we can transcend the limitations of the 10% myth and embrace the true capabilities of our minds. This journey towards whole brain thinking is not just a path to personal growth, but a gateway to a more enlightened and fulfilled existence. As we journey further into understanding our brain's potential, we encounter the concept of brain dominance. This phenomenon describes how one hemisphere temporarily takes the lead in processing information, depending on the task at hand. For instance, when we solve a mathematical problem, our left hemisphere may dominate due to its analytical nature. Conversely, when we are engaged in a creative activity like painting, our right hemisphere might take the lead. This oscillation between hemispheres is not a flaw, but a feature of our cognitive architecture. It allows us to adapt to different challenges and environments by leveraging the strengths of each hemisphere. However, an over-reliance on one hemisphere can lead to an imbalance where we become too analytical and lose touch with our creative side, or become overly abstract and lose our analytical precision. Understanding brain dominance and its oscillatory nature helps us appreciate the dynamic interplay between our cognitive functions. Just as a well-orchestrated dance requires both partners to be in sync, optimal brain function requires both hemispheres to harmonize and take the lead when appropriate. This balance ensures that we can tackle a wide range of tasks with agility and depth. Achieving brain synchronization is not an abstract concept, but a practical goal that can be pursued through specific techniques. Mindful breathing and meditation are powerful tools in this quest. By focusing on our breath and calming our minds, we reduce stress and promote cooperation between the hemispheres. Meditation creates a state of mental clarity and tranquility, fostering a balanced engagement of both logical and creative faculties. Cross-lateral movements, such as those found in activities like swimming or yoga, are another effective method. These movements require coordination between the left and right sides of the body, thereby stimulating communication between the brain's hemispheres. Such physical activities are not only beneficial for our physical health, but also enhance our cognitive synchronization. Engaging in creative pursuits can stimulate both logical and emotional centers of the brain. Activities such as painting, writing, or playing a musical instrument require us to draw on both hemispheres, blending analytical skills with creative expression. These pursuits help us break free from rigid thought patterns and encourage a more holistic approach to problem solving and creativity. Brain training exercises, such as puzzles, memory games, and cognitive challenges, can also enhance our brain's synchronization. These exercises push us to use different parts of our brain, strengthening the connections between neurons and promoting overall cognitive health. Regular practice of these exercises can lead to significant improvements in mental agility and flexibility. While practical techniques can foster brain synchronization, breaking free from habitual patterns is crucial for unlocking our full potential. Habitual patterns, though efficient, often limit our cognitive flexibility and constrain our growth. These patterns are formed by repeated behaviors and thoughts, which reinforce specific neural pathways while neglecting others. To disrupt these patterns, we must consciously engage both hemispheres of our brain. This engagement can be achieved through novel experiences and challenges that push us out of our comfort zones. By exposing ourselves to new activities and perspectives, we stimulate underused neural pathways and foster a more adaptable and resilient mind. For example, if we typically rely on our left hemisphere for logical tasks, we can challenge ourselves by engaging in creative activities that stimulate the right hemisphere. Conversely, if we tend to be more creative, we can strengthen our analytical skills by tackling logical puzzles and problems. This conscious effort to engage both hemispheres disrupts habitual patterns and promotes cognitive growth. Breaking free from habitual patterns also involves mindfulness and self-awareness. By being aware of our thought processes and behaviors, we can identify patterns that limit our potential and consciously choose to act differently. This mindfulness allows us to create new, more flexible patterns that enhance our cognitive abilities and personal growth. In our quest for personal transformation and fulfillment, brain synchronization emerges as a key principle. By understanding and harnessing the dynamic interplay between neurons and glial cells, and by achieving harmony between the left and right hemispheres of our brain, we unlock our true potential. This holistic approach to brain function is not merely an intellectual exercise. It is a pathway to profound cognitive flexibility, creativity, and personal growth. The journey towards whole brain thinking is not just about improving our cognitive abilities. It is about redefining what it means to be human. It invites us to explore the depths of our consciousness, to harmonize our inner and outer worlds, and to realize our fullest potential. Let us embark on this journey with curiosity and commitment, knowing that the rewards are boundless and the possibilities infinite.